Hello and thank you for watching my video. My name is Astrid Krasniqi. I'm CCNA and CCNP certified instructor. Today I will do a demonstration on configuring RIP version 2. This is packet tracer 7.3.1.8. Okay, let me just open my packet tracer files. So RIP version 2. Okay, now the packet tracer has loaded. I'm gonna cancel this user profile. This is my topology. I've got router 1 is connected to a local area network. Router 2 it's got its own local area network, as well as router 3. And they are connected to the internet, and we need to be able, in the end of this activity, we need to be able to ping this web server. Okay, so I'm gonna move my topology to the right here and look at the activity. So objectives for this activity is to configure RIP version 2. Then part 2 is to verify configuration. A small background. Although RIP is rarely used in a modern network, it is useful as a foundation for understanding basic network routing. In this activity, we will configure a default route, RIP version 2, with the appropriate network statement and passive interfaces, and in the end, verify the full connectivity. Okay, so in part 1, configure RIP version 2. Step 1 says configure RIP version 2 on router 1. So use the appropriate command to create a default route on router 1 for all internet traffic to exit network through serial 0/0/1. So all the internet traffic is gonna go out of this interface. Okay, so I'll open router 1, CLI. Enable, and then configure terminal. Configure terminal. In here we create a static route. We want to create a default static route, which is IP route all zeros with any netmask, and its exit interface is a local interface. So S0/0/1. That's what it said there. Yeah. Okay, excellent. Now, enter RIP protocol configuration mode. So from here, we say router, and I can hit the question mark. In packet tracer, it does support only BGP, EIGRP, OSPF, and RIP. Now, in the real routers, you will see a lot more protocols available for you, like ISIS and so on, ODR and so on. Okay, so router, RIP, and enter. Now, that's how we enter RIP protocol configuration mode. As you can see, the mode has changed, config, and then router, which means that we are in router configuration mode. Use version 2, okay? So we need to type version 2, enter. And then it says of the RIP protocol, and disable the summarization of the network. So by default, RIP will auto summarize. But we don't want that, so we're gonna say no auto summary. Okay. Now configure RIP for the network that connects to router 1. So we have to look at the router 1 and find out what networks on the router 1 are there. So we're gonna configure RIP for that. So router 1 has got network 192.168.1.0 LAN network, and it's got connection to 192.168.2.0. So we need to configure and advertise those two networks to the neighbors. So I'll have to go to the router 1, type network 192.168.1.0. Just gonna check them again. .1.0 and 2.0. Okay. .1.0, enter. Network 192.168.2.0. So what I'm doing with this is I'm saying to my neighbors, okay, here's my networks. This is what I know. This is what I'm directly connected. If anybody wants to know this information, find it useful, put it on their routing table. This is what you advertising to the neighbors. Now, the next one says, configure the LAN port that contains no router so that it does not send out any routing information. So by default, because we have enabled on this port And on this port, for these two networks, so by default, router RIP will send advertising this way every 30 seconds, and it will send advertising this way every 30 seconds. So, but this way we don't have any router. So because we don't have any router connected or any neighbor, potential neighbor, we can stop these advertisers on that link. So what we can say is passive interface, I think it's G01. Let me just check what interface is it. If I just hover, G00. G00. Okay, if you didn't know, I can just do show IP interface brief and then find out what interface or interface. Then I can find out, okay, well, this is the network that I want to advertise, and this is the network that I want to advertise to my neighbors. I do not want to advertise a network that I'm connected to the internet because I have a default route to that network. So I can do end here and show IP route. So at the moment I know about only my directly connected networks, which is 3 in total, right? One LAN, this is LAN 192.168.1.0. This is serial interface towards router 2 192.168.2.0, and this is a connection towards the internet. So I know my directly connected networks, plus I know the static network that we created, or static route that we created. Okay, excellent. Let me shrink this a little bit. Okay, advertise the default route configured in step 1 with the other RIP entries. With other RIP routers. So on router 1, so config T again, router RIP default information originate. So at the moment I'm advertising anyone that speaks RIP language, or it's gonna hear my RIP updates, it's gonna hear that I've got a default route to the rest of the network, or to the internet. Right. Okay, save the configuration. So if I go to router 1 again and copy running config, startup config, enter. Destination file name startup config, true. Okay, we move to step 2. Now let's see what step 2 says. Step 2, enter RIP protocol configuration mode on router 2. So we have to go to router 2, open router 2. Okay. So we are in user mode, enable, then configure terminal, then enter RIP protocol configuration mode. So router, RIP, that's it. Use version 2 and disable auto summary. So version 2, no auto summary. Done. Configure RIP for the network directly connected to router 2. So we need to find out what is connected to router 2. Router 2 is got 192.168.2.0 connection towards router 1, 192.168.3.0 connection towards LAN, 192.168.4.0 connection towards router 3. That's 3 directly connected network that he has. Okay, so I'll go to router 2, say network 192.168.2.0, enter. Network 192.168.3.0 and network 192.168.4.0. okay, network, enter. Okay, I'm advertising 3 networks towards router 1, route LAN, and towards router 3. Okay, configure RIP for the networks directly connected, which we did. Configure the interface that contains no router so that it does not send any routing information. So this way, towards LAN doesn't have any router as a neighbor. So we don't want to send any routing updates that way and waste the bandwidth. So we go to router and say passive interface G00, I think. Okay, let's find out what is the interface. If I just hover above it, G00. Okay. Passive interface G00. What you could do is passive interface default, and then you will have to do no passive interface where you want to send the updates to. Okay, we've done that. So save the configuration. So we have to end and copy running config to startup config. Okay. Now configure RIP version 2 on router 3. Repeat the steps for as we did on router 1 and router 2. Okay, so I'll have to go to router 3. And router 3 is got connection to 192.168.4.0, 192.168.5.0. Okay, so CLI. Okay, enable config T, and then router RIP version 2, no auto summary, and then advertise the network. So network 192.168. What was it? Let me just go and check again. 4.0 and 5.0. 192.168.4.0 and network 192.168.5.0. Okay, we do want to send not send any updates towards our LAN, so we're gonna put that interface in passive mode. So I have to go to router 3, right? So passive interface G00 and copy running config to start our config. Okay, done. It's 100% out of 100%. We have completed the configurations. Now, part 2 is verifying the configuration. View routing tables on router 1, router 2, and router 3. Okay, use the appropriate command to show the routing table on R1. RIP R now appears when connected with connected C and local L. Routes in the routing table. All networks have an entry. You also see a default route listed. So if I go to router 1, for example, and do show IP route, right? Now press spacebar to go to the end, and I can see my directly connected networks that were there before. Okay, and this one as well. But I have learned this route, right? That's the first route. 192.168.3.0. I have administrative distance is 120. The metric or hop count is 1, so I know it's directly attached to my neighbor. And I'm learned it through 192.168.2.2, which is my neighbor's IP address. And for 20 seconds, and in serial interface serial 0/0/0/0. So this is what I've learned it. I learned it in this interface, and this is the IP address that I need to go if I want to send any information to that network. I have learned the second network through RIP, which is 192.168.4.0, and this is same. Administrative distance is 120 and hop is 1, which means it's directly connected to my neighbor. And I will use my neighbor's IP address and my exit interface serial 000 to get there. Then I learned another RIP update from 192.1 to the network 192.168.5.0. This is administrative distance is 120, but it's 2 hops away, which means it's not directly connected to my neighbor, but it's directly connected to my neighbor's neighbor. And I will still use 192.168.2.2 to get there. Exit interface will be serial 000. And I have a default static route. So I have a static route with a star there. That star represents potential to be a default route, and is directly connected out of the exit interface serial 0/0/0/1, which says here as well, gateway of last resort is all zeros to the network all zeros. Okay, now if I go to router 2 and I'll run the same command, show IP route. Now here I can see information as well, all my directly connected networks, and then some RIP routes I'm learning. To see only RIP, right, we do show IP route RIP. And now I'm not going to see my directly connected, I'm just going to see the routes that I'm learning through via RIP. So I'm learning the first route is 192.168.1.0, administrative distance or believability is 120, and it's one hop away. Through my exit interface, or exit interface is 0000, but my neighbor's IP address is 192.168.2.1. I've got another route here, learned 192.168.5.0, and then this is through my other serial interface, or my other serial interface on router 2, and it's learning a default route that says for any network, right, I'm just going to send it to my neighbor 192.168.2.1. And I'll repeat the same command for router 3. So router 3 to show IP route RIP, and here I can see all my 3 RIP networks I'm learning, .1.0, .2.0, and .3.0, and you can see that .1.0, because router 3 is learning everything from router 2, so you can see that to get to the network of router 1, the LAN of router 1, it's going to be 2 hops, 1 hop, second hop. So you can see there, it's 2 hops away. And plus it's got a default gateway that says, okay, well, anything that I don't know, I'm just going to send it to my neighbor 192.168.4.2. Okay, now we view the routing table on R2 and R3. We did. Notice that each router has a full listing of all 192.168x networks and a default route, which we saw. Every device should now be able to ping every other device inside the network. In addition, all devices should be able to ping the web server. So if I go to the network, right, so what I'm going to test, PC1 to ping PC2 and PC3, and then ping PC2 to ping PC3. If that communication is successful, then we know the whole network is working, plus PC1 to ping the web server. So if I go to PC1, I open all my PCs. So go to PC1, open PC2, command prompt, and PC3, command prompt. Right, so if I go back to PC1, so on PC1, let me just move this to here and say IP config, just to see my IP address there, 192.168.1.10. So if I go to PC2 and I'll move this to this side, and I'll do IP config 192.168.3.10, and I will do for PC3, I'll move PC3 down here, IP config 192.168.5.10. Okay, so ping this address 192.168.3.10, 192.168.3.10. Okay, let's see. We're gonna lose few packets because of ARP resolution. Okay, so first packet is get lost because of that. It timed out while we are resolving IP address to the MAC address, and then every other ping is fine. Now we can repeat the command as many times as we want. We're not going to lose any more packets. Just the first packet while you are resolving with the ARP. Okay, so from PC1 to PC2 is working. From PC1 to PC3, let's try that. So ping, and we're going to ping that address 192.168.5.10. Okay, again ARP, and then we got reply, which is great. PC1 can ping PC2 and PC1 can ping PC3. Now PC2 should try ping PC3, so ping this address 192.168.5.10, and we got reply. Excellent. The last thing we're going to test is we're going to test that we can ping the web server 64.100.0.10. So ping 64.100.0.10. If we have a reply, PC1 can ping all the way towards the internet and back. Excellent, that worked. So I'm gonna go to PC2, do the same. So ping 64.100.0.10, that's the web server's address. I got a reply. And the same for PC3. So I'm just going to move to PC3 a little bit. So ping, the web server's address was 64.100.0.10, and I got a reply. Excellent. I can check results if I want here to make sure that everything is ticked. Should be. Okay, excellent. Here you can check if you missed something or you need to redo something. Usually if you haven't done something, it will be next there. Thank you very much for watching this video. This has been Astrid Krasniqi demonstrating you how to configure RIP version 2. See you on the future videos.